Hello, my name is Mojtaba Afzali. I am a master student in Energy and Environmental Technology at University of Southeastern Norway. My master thesis title is Modeling of Evaporation of Hydrogen During Accidental Releases. My main supervisor was Professor Andre Gotok, and the external partners were H2 Maritime and Moses. As we all know, the world is suffering from global warming and environmental issues. And the origin of these issues are substantial growth of CO2 production by using fossil fuels. So hydrogen is a possible carbon-free energy carrier for the future, or maybe for the present. So it can be used, and the only byproduct of its combustion is water. For ease of transportation and storage of hydrogen gas, we have to liquefy the gas by raising the pressure on the gas, or by lowering the gas temperature to a freezing point. So liquid hydrogen is a cryogenic liquid that has a boiling point below the ambient temperature. It means that after a spill of some amount of liquid hydrogen, it will evaporate vigorously. So a vapor cloud forms and diffuses, and this may cause explosion or pool fire. So problems arise with wide use of liquid hydrogen concerning their safe storage, transportation, and application. And as an initial step of safety, the evaporation of hydrogen during accidental releases must be understood, and a model of evaporation should be available. To obtain this objective, available mathematical model from literature review on the release of cryogenic liquids has been conducted, and after that the available mathematical models has been chosen to model the operation of hydrogen, and experimental data is used for model validation. After literature review, it can be found that integral model, shallow layer models, and CFD models are available. That in this work, an integral model has been chosen to model the evaporation. These integral models are namely Briscoe-Shaw model, constant for the number, and gas accumulation over a spreading pool model. For modeling of the evaporation, we have to also consider the spreading pool. After a spill of some amount of cryogenic liquid, it will spread over the ground, and it will simultaneously evaporate vigorously. So the pool boiling and spreading should also be considered. For obtain this objective, different correlation for different regimes, different boiling regimes are investigated, and as you can see here, different correlation proposed by different researchers has been investigated, and in the end the boiling curve of hydrogen is plotted. For modeling of liquid hydrogen spreading and evaporation, Briscoe-Shaw model as a first step is used, and as you can see here, it is a system of coupled differential equations that should be solved numerically, and it produce a roughly good graph that is in good agreement with experimental data. And also the gas model, the original gas model, which found difficult to solve numerically due to enormous range of time scale. So a simplified model of gas is used to model, and as you can see here, it is in a better agreement with the experimental data than Briscoe-Shaw model. And CFN model also is used, that is a modified version of Briscoe-Shaw model. And it can be seen that this model also in roughly good agreement with the experimental data. As a conclusion, we can say that the gas model is in better agreement with the experimental data, and CFN and Briscoe-Shaw model should be investigated a little more for improvement. Thanks for watching this video. This is the end of my presentation.